Hello, everyone. Welcome back to another episode of Destination Big Leagues. In today's episode, I've got Rod Rivera. He is part of the AI engineer community. It is an AI community to help people integrate AI into their workflows. Thank you so much, Rod, for coming on to the podcast. So, would you like to quickly introduce yourself? I know you've got a lot of tenure of experience. You've worked at Samsung, Alibaba, Philip Morrison. Uh, could you just quickly run through, how you've got to the position you are and your current role at the AI engineer?
Thank you, Rona, so much for having me. I'm thrilled to be here today. I'm originally from Mexico, but it is so that I've been involved with data, everything's got to for machine learning, data science, and so on, for now more than 10 years. Back when I started, there was not even the title data scientist. I was very excited about it, and I was looking where can I work as a data scientist. And besides some very rare positions in the United States, this was not something that was common. This happened about 4 or 5 years later. So it has been already a while, and in the meantime, I have pretty much seen all the spectrum of tasks in data science and machine learning. I also did a PhD in machine learning, and I've been active entrepreneurially. I've done a company in the machine learning space. I've also been leading teams at large organizations, startups, but now my focus is really to help people adopt AI applications and that they can do it effectively and easily.
Awesome. So really looking forward to having an exciting conversation with you. So, you said you've got your PhD in machine learning and data science is still relatively quite a new term while it's currently mainstreamed, like 5, 10 years ago, the word data science wasn't there. So what do you see the major evolution in terms of the data science machine learning field, that has led to massive proliferation and every sort of SME to enterprises really like trying to, get their data science cracked on.
Yes, so much has happened this time, but if I look at a specific trend, what I identify is how we have gone towards simplification. Meaning, so back in 2011, 2012, there were so many methods that one needed to know that were very esoteric. There were no resources as there are today. So maybe like some books and some experience. Also at universities, maybe there were some seminars where people were talking about this. So it was something very exotic. And one needed first to get acquainted to that. Then the trouble was the software itself. There was already scikit-learn, pandas, some of these PyData stack tools, but it was still relatively hard to use them and integrate them and so. And now all this is gone. Now we have a wealth of information. We have also a simplification, not only on how we work in our workflows, but also in which models we need to know. For example, now we know that for tabular data, intuitively we'll just apply some random forest tree as a baseline, and likely this will give great results. 10 years ago, that was not the case. So it was not really, there was not even EG and so on. That came a bit later. So we have a simplification in techniques that we have now go-to methods to always get reasonable results. And then, of course, now we have all the advances with L.L.M'S that simplify this even further. So now it's starting to become a bit of a black box where even it's not necessary to know really how things work in order to get great results. And 89% of the time, 90%, it will work.
Right. So, recently, over the past year, since OpenAI released ChatGPT, generative AI is proliferated massively. Everyone's really trying to figure out, within their business how they can kind of get a product based around generative AI. What do you see the major differences between kind of traditional machine learning and generative AI? I know you've spoken a little bit about it being a black box and stuff like that, but what is the main difference between traditional machine learning and this new field, generative AI?
Yes, for me, the largest difference is how it can be generalized. Where, for example, if you were a data scientist who is working at a bank, and then you will build your models, and then you say, hey, I'm moving to another bank or maybe even another position with the same bank. Most of these models, basically almost all of them, you will not be able to just take them and reuse them. Um, you will need to start from zero. You'll need to get new data, cleaning, maybe look at different models, benchmark them, and so on. And only then you could do something. So it was so classic machine learning is tightly coupled to the data at hand. Whereas all these foundational models, base models, L.L.M'S, is almost the opposite. So I can take this large language model, be whatever it is, and then use it across not only different companies in the same industry, but also different industries without needing to do major modifications.
That's interesting, right? So, what has been the architectural shift that these models are so generalized across a wide corpus of data, right? Like, as machine learning has been quite domain specific, what has been the architectural breakthrough that has made generative AI, such a generalized model where it can fit into any sort of context?
Well, it's definitely the mix of using the attention mechanism together with reference architecture. But we already had this back in 2016. In fact, so the attention mechanism is even older. So this has been already for a while. But really, what changed was to say, hey, let us really feed it with what one could call big data in a sense. So let us put all the internet, all knowledge that we have available on the public internet, and use this as our training set. Whereas before, yes, we will be using also transverse architectures, also attention mechanism, but it will be with much smaller data sets. It will be much more point tasks with very specific objectives.
Right. So, you mentioned about attention mechanism, right? Can you kind of explain what attention mechanism is?
Yes, so the idea with attention mechanism is that we have to think so that, for example, if we have a sentence, a sentence so of any length, the challenge with machine learning methods has always been which part of this sentence is relevant so for any type of task, for example, so for predicting next word or for trying to classify or getting a topic and so on. And of course, the longer the sentences, the more complicated it gets. And normally, the methods, what they will do is they will assign some sort of weights based on the recency. And as the input will get longer, the older words will start disappearing in terms of how relevant they are. What happened with attention mechanism was a very smart way in saying, hey, actually, a lot of meaning can also be inside early in the sentence or in the middle of the sentence, so that doesn't matter. What we need to just keep track is to keep track of how these words stay in relation with each other and also in which part of the sentence they are. So this enabled basically to have much longer inputs. So historically we had other techniques such as LSTMs, CNNs, or even earlier Markov processes that were very popular for predictive tasks in sequences, language, and so on. But they always had this situation of the longer the input, then the harder it was to give relevance to input that was much older.
Right. That's a pretty good explanation. So, I think, as you mentioned, the GPT, well, the GPT architecture was published by Google. It was in the paper, Attention is All You Need. So, Google had kind of first had the overall architectural sort of thinking of, how GPT could be a way to kind of have deeper understanding of text. But when you look at OpenAI, the reason why ChatGPT was so successful was because of the RLHF mechanism that they integrated into that, which increased the accuracy of the outputs. How significant do you think RLHF was, as a key pillar for ChatGPT's success?
Um, well, I would say that there were multiple factors that contribute to success of GPT models. But in fact, of so here using reinforcement learning, I see it as a very smart approach in that in the end we need to have some sort of human in the loop evaluating. And we already had this so throughout the years. So where, for example, if we are running a large scale machine learning system, we'll try to include some humans through something such as Amazon Turnpike, who will be evaluating the results so from our classifier or just our regressor or whatever it is, and saying, yeah, this was good or not good, and then if not, then what was the actual outcome. So this has been already relatively popular for this type of large-scale systems. But then what happened so here with so OpenAI was not only in doing this scale and also with so corpus on the internet, but also like doing this continually. So they continue doing this every time. It's not a one-off activity. And plus including the fact of using reinforcement learning. Before we'll use like maybe more simpler approaches such as majority voting. So I have a three person who say this is wrong, so this must be wrong and so on. So it was a bit more naive how we were doing it. So this mix of combining something existing with something a bit more novel is what makes them more effective and more interesting as approach.
Right. So, uh, basically LLMs are kind of black boxes, right? The input you put, the output, you can kind of determine the probability of the output it's going to give you, but it's really hard to deterministically predict the behavior of LLMs, right? So let's say someone was to try to productionize a generative AI use case within their business. Uh, you know, how should they get around like monitoring the performance and then creating metrics to determine their sort of performance for their LLMs?
Well, this is a thriving and ongoing topic in the community where, compared to classic machine learning methods, we do not really have yet a standard. So, on one side of metrics that we can use to benchmark them, and on the other side of data sets, there's always, for example, here the risk that if we use public data, then this is already inside what was used to train this LLM model. So, as a result, it will be contaminated. So it becomes difficult to generalize where if I have multiple models and so on, then how do I evaluate them? And also, how can I validate my claims, let's say, for example, with the other community, if I don't want to expose this data such that it will not be absorbed by another model and train with that. So this is one thing. But then it's a question of, okay, so now I'm doing an AI application, and so what can I do? Um, well, the one common technique is try to use generated data in using this in order to evaluate some response. Basically, so using one LLM, so for another LLM, and this works. But at the same time, there are studies that show that in the end, so generative data never compares to all the synthetic data never compares to actual humans. So ideally, if one will try to involve humans. This can be so something complex such as Amazon Turnpike and so on. But this can be something simple, such as trying to do some sort of like focus groups, etc. But then here again is the challenge that likely it will not be possible to do this on a large scale and all the time. So it is a challenge for sure. And I think that at the moment, like the best that we are doing is on one side, trying to constrain so the outputs, trying to use architecture such as racks and similar, and a little bit of hacking our way around. But it's still that, it's still very hacky everything in a sense.
Right. So, you mentioned RAGs, right? Retrieval augmented generation. Everyone within the AI space and LLM space has been talking about RAGs, how to optimize their RAGs. What are RAGs, and what is the purpose of RAGs?
Yeah, so the idea of racks is that so the LLM is a general model, but of course it was not exposed to our internal data, our proprietary data, or our problem. Um, it can be that it had a bit of exposure, but still it is a generalist. So how can we try to make it more of a specialist without needing to fine tune or retrain this model or distill it and so on? So let's say by adding things on top. And what we realized was that we can have large context windows, meaning we can have large inputs into these models, and the prompt query that we can put is rather short. So there's space to add more things. So the other for Access is the following. So we have a corpus of data. We convert this corpus of data into a set of vectors. We store them somewhere. And then when we send a query, um, so let's say, for example, um, how do I record a good podcast? Then what happens is that before this query goes to the LLM itself, it will go to this database that had all these vectors stored. It will try to find the closest vectors to this query, and then it will give the query together with these vectors to the LLM, and then LLM chooses based on these constrained and reduced so input, such that it doesn't use its full knowledge, but rather it focuses only on what we're providing that likely is much more precise than the knowledge that the LLM itself has.
Got it. So it basically does like a semantic match on the vector database before passing on to the LLM.
Yes.
Right. And yeah, that's actually a pretty interesting mechanism, right? So therefore, you can kind of have larger context windows. You can provide much longer prompts, and it becomes more efficient, essentially.
Well, in it is more about so tailoring it for our problems. So, for example, if we think about so the classic use case is at companies chat with your data. Then all these documents are internal documents, so they have never been in the internet. So it is impossible that the LLM knows about it. Plus, on top, we have always with LLMs that we do not know, or we know that the code date when it was last trained, it might not be current. So, for example, if I'm a financial institution and I just want to know which are the largest companies in the market, well, likely if the model was trained 1 year ago, some months ago, this might have already changed. So I need to provide this fresh information somehow. And then one easy way to do this is through RAG architecture.
Got it. So, while talking about the RAG architecture, you kind of spoke a little bit about fine tuning and stuff like that. When should someone decide like to kind of build on their RAG architecture versus, reach a point where like, okay, this is at this point in time, we should probably think about investing in fine tuning.
Yes, so here there are multiple, there is a set of criteria in order to choose between, so should I go for a RAG or should I try to create a smaller model, so fine-tuning model and so on. One of these is, so you mentioned it, this is having budget. So where with RAG, I don't have basically to pay anything. I can do it even on my home computer or my laptop and get some results. So it's very easy and fast to get a prototype that I can show to someone. Also, I do not need to be a super expert in machine learning. So if I'm just a software engineer, I can build a RAG application because in the end, a RAG application is engineering, is let's say like gluing pieces together. Whereas if I say, hey, now I will try to so fine tune my model with data, this means I need to be a machine learning person. I need to know how things work. I need to know what I'm doing. Plus, on top, I need also to have a budget. So at the moment, um, retraining a model, it costs, depending, of course, on the size of the model and what we're doing, definitely somewhere between $1,000, $2,000 in total to have this smaller fine tune model. And obviously, not everyone has access to these budgets. So if budget is a problem, then already this excludes doing something with fine-tuning the model. But then if the budget is not a problem and my company can afford it, then it comes down to the question of so the context length. Even with the largest models in the market, there is a limit on how much input I can put into it. So if I have, let's say, like billions of documents and um, then obviously it will not be feasible to work with the rack if I'm trying to pass a lot of input that's much larger than this context input. And then I would say like the other one is also this time to market. So where for sure working with racks is something that is much faster. So I do think that here I find that racks is like a go-to option. So where if I want to show results, for example, at my organization, I want to show hey AI works, then makes a lot of sense to just start simple with a rack application, show it in a limited use case, and then if everyone is excited, then look into going to something more complicated, such as trying to get better models, distill models, and so on.
Right. So could we say that fine-tuned models would outperform RAGs? Like if someone was willing to put that investment in terms of fine-tuning their model, would it would it generally perform better than RAGs, or it's not certain? It just depends on how you fine-tuned your model also.
I would say it's not certain because so doing this fine tuning, it becomes a pure data science machine learning problem where I need to find the right LLM for my task. So there is by now a zoo of models available. And it might be that for my task, I didn't get the best one. I overlooked something. And this is one thing. The other thing is also that then I need to also prepare my data. I need to work into like training the model, get an understanding of which parameters to initialize and so on. So it really becomes something where one needs to have experience, and likely in the beginning we will basically not doing it in the best possible manner. So yes, if one is a super expert and one has done it many times, likely so by fine tuning we might get better results. But let's say if we are starting the field, I'm not sure that by trying to get your own model through fine tuning, one will beat a RAG application.
Right. Okay. So, there is a wide corpus of LLMs out there. There's the open source and then the closed source community, like with what OpenAI has been doing in terms of their closed source code community and Bard and stuff like that. Uh, so, when kind of building an AI application within the large corpus of data, first, how does one choose between open source and sort of not open sourced LLMs? And then after that, how does one even choose which LLM is the best LLM to use for their specific use case?
Yes, so it's a huge debate between open source and so closed source models, cloud models. There are pros and cons, and there is not a definitive answer. So here, but reality is that at the moment, these cloud models, so by OpenAI, Anthropic, and so on and so forth, they offer more comfort for the mm, so regular engineer. It is much more easier. They have documentation, and they are more robust in general in terms of interacting with them with their APIs. So if one is starting, then this is always a great point. With the open source LLMs, there's still a lot that one needs to do, a lot that one needs to hack around in order to like get this running, and then on top to get the results that one wants. And this means that if one is just started, yes, so it makes sense to go with a cloud model. Obviously, cloud model costs money. There is also other considerations. So, for example, models get deprecated. So, one thing that we have realized is that prompts are not almost always translatable across context. And with this, I mean, if I craft a really good prompt that works with GPT-3, there is no real guarantee that if I move towards using so something from Anthropic or any other provider in the market, I will get as good results. So I will need to do it so from almost from the start in what I was building. And then it's also the situation that yeah, one becomes dependent to the provider. And in the recent weeks with all this turmoil that happened at OpenAI, for many companies it became obvious that betting on one single vendor can be a point of failure that can lead to consequences. Now, from reports, around $1 billion are being spent on GPT models from companies all over the world. So now a lot of serious business is already being done on OpenAI with LLMs. And what happens if, for some reason, OpenAI disappears? It will be a catastrophe. So this also comes to that. So how? So what level of reliability do I need? And then with cloud models, it's also the topic of I'm giving my data to an external provider. So this already means that for many organizations in healthcare, in finance, or just organizations that are secretive, for example, defense sector, well, obviously, working with cloud models will be rather a no-go, and then they will rather explore into working with cloud open source models. And then in open source, what do we have, or what are like some pointers? Well, I think that what is happening with Llama CVP is super exciting. I do think that if one, especially if one is a single hacker and does not have access to many resources, Llama CVP is really the best option that is out there in order to start doing things. Because with Llama CVP, I don't need a GPU. This is another thing that so with any type of open source models, I will need to use a GPU somehow, be on the cloud or locally on my computer. With Llama CPP, I don't require that. I can just work with my CPU, and Llama is a very robust model. But I think that now, so for example, Llama, Orca, also Mistral, they have their position themselves as really the natural go-to options. Just if I'm starting, and then of course once I have get a feeling, then I can start exploring other models. But basically, these three are so good starting points in the open source space.
Right, right. So, you kind of mentioned GPUs, right? In the Llama model, you don't have to use GPUs, which is big, right? Actually, GPUs are kind of a quite interesting topic, right? Because, traditionally we had, it was all the processing was done in our CPUs, and then we had like tensor processing units, and now a lot of the latest models are being trained on GPUs. Can you kind of explain to, our audience in terms of like, why has GPUs gotten so much demand? Like, if you just look at Nvidia's growth, it's kind of this like linear trajectory, and over the past couple of quarters, it's just a straight up hockey puck. Shoot, why do training these LLMs require GPUs and so much compute?
Yes, so we have to go back to pretty much 2010, 2011, and so when so deep learning was really starting to show very promising results. And what happened is that in the end, deep learning is pretty much linear algebra. So we're working with matrices and vector spaces, and we need a very efficient and fast way to do computation on these vectors. And we historically had access to CPUs, which they are more of a general tools. They are not optimized for this type of vector computations. But we already had a vector work, vector task in other fields. So in the whole video game programming field, so where we will need to have these tree structures are also vectors. And NVIDIA was already established in the market as the company providing these video cards, these GPU cards, that enable gamers to get good results, get very nice graphics, and so on. And it was possible because they were really tailored for processing and doing operations on vectors. So it's one thing already that it was a much more specialized solution compared to CPUs. Then also NVIDIA put a lot of effort into the tooling. And then also here, as a side note, it is that when people show, oh, there are other competitors trying to bring alternatives to NVIDIA GPUs, what I say is, yes, this is great, but it's unlikely that this will change much in the market because NVIDIA, with its CUDA platform for programming, has already such a vast control of the market that even if other competitors appear with better hardware, they will likely not have that good of a software, plus the community already doing things, and as a result, it will remain niche. So this is like the other thing that was a big differentiator, and why also, so it was Ilya Susteker, who is now at OpenAI. So he was pretty much like the first person who realized, hey, I can work with GPUs and I can program these algorithms in CUDA, which is this very low level and so programming um, language that allows to work very close to the metal, very close to the video card, and do these computations on my so to process these vectors.
Right. So, okay, so just talking more into kind of GPUs, right? A lot of the things that we've previously talked about, AI, generative AI use cases is basically like relying on an existing LLM like OpenAI or Google's or Claude, Anthropic, etc. Right? Let's say if there's an entrepreneur who can kind of somehow get the funding, you know, buy an X amount of NVIDIA GPUs, how would someone go about sort of training an LLM from scratch? What would the average amount of GPUs take to kind of have an LLM that is of decent parameter size? Let's say about, I guess, 20, 30 billion parameters. How much would something like that cost?
Well, so here it is. I bring it back to this topic of I mentioned that it costs these days around $1 to $2,000 to fine tune the model. And this is because one needs to basically run it for so quite a few hours. Let's say like around 20 hours or so. But most of the time we do not get it right, so we'll have to do it multiple times when this adopts. And then we need also to at least work with 3, 4 like large GPUs. So something that we do not have in our home computers. So this is really using AWS or another cloud provider in order to get more of a beefy, robust GPUs. And then it comes down to also how good of a fine tuners we are, because the thing is that this is still almost like alchemy. And with that I mean that it's not like there is a book or somewhere where I have really this point of saying, hey, this is how you can initialize it, and this is like the best practice and so on. It's still very like mouth to mouth, all this knowledge. A lot of this is happening. For example, there are these logbooks that are on Git where people document, oh, this is how I train this model, and then people see, oh, these were the starting parameters, this is where like experience, this is when they stop the model, and so on and so forth. So they get a feeling, and then they can use a starting point. But it's still, yes, almost like a craft where based on empirical experience that it worked once, then I go and try to do it again. But it can be that in the end, this is not really translatable to my problem at hand. It can be that this logbook that I'm looking at is suboptimal for the problem itself. So here is also that the cost will vary a lot into, let's say, in which local optima I landed looking for models, looking for how to initialize them, and just what I find on the internet how to do it.
Right. I actually love that you mentioned it is kind of like alchemy, and I totally agree with you. You know, it's really difficult to transfer one of the methods into another foundational model because the performances are quite different. So that's actually pretty interesting. It's the first time I've heard someone saying it's kind of like alchemy, which is an interesting way to kind of think about it. Google's kind of getting heated up in the LLM space. A lot of people, were underestimating Google. They were like concerned on terms of has Google kind of taken the backseat on AI and stuff like that? And you were seeing OpenAI sort of create a lot of the excitement, capturing a lot of market share. Uh, Over the past couple of days, Google released Gemini. They made a pretty interesting 6-minute promo, which seemed quite impressive. What is your opinion on Google? Do you think they're playing catch up? Do you, in your opinion, see that they will eventually surpass OpenAI? Uh, yep,
I will never discount Google, just alone for the fact that this is an organization that has DeepMind, and DeepMind has basically so some of the best researchers in the space. Plus, on top, you mentioned that so attention is all you need came originally from Google. So the people are there, the knowledge there. They have all the compute power in the world in terms of data centers and so on. So all the components were there. And when people so think, oh, they were lagging, or so for example, BART was not that good compared to GPT and so on. I just think is in the end also is a big organization. Big organizations have many moving pieces, and sometimes it takes a while to so to say heat up the engine and get things going. But now it's obvious to everyone that so AI is not only future but the present, and then as a result, we can see that they have um, organized things in a way that they can focus on this and get the results that they have. And however, on the topic of will it surpass OpenAI, will it be the same? What I do see is that well, we're headed towards a situation where this will be complete commodities, a little bit like, for example, if we think about in the hardware space, so with microchips or even GPU cards, so where sure there is always top of the line, top performance, but for the average person, they do not even really know what's inside the computer, and they realize so is somehow fast it actually works, and we'll be headed into this situation where we will get a good baseline everywhere, no matter what we're using, and then there will be some differences here and there, but this will really become a commodity. In fact, I'm a big believer that we will move towards complete local models that are running in our systems. So even it might not be necessary to work with cloud models at all. Maybe I have a very complicated task, I might use of these cloud models, but let's say for my bread and butter activities, it will be just as, for example, today in data science, I can spin up an instance with a Jupyter notebook, and then I have there my Python environment and everything that I need, and I don't need to go and then so work with the cloud server. I see same thing with the LLM models that they are getting small enough and efficient enough, and so don't require enough resources, such that we can just run it locally in just our home laptops.
exactly. Yeah, I think a lot of it is headed towards, like, as you said, the general model is just being commoditized, and everybody getting access for it for probably no cost. And I think like a lot of these models will eventually be able to run locally. Thinking about like how much our chips and computers are also going to evolve. So a lot of the basic tasks probably could just run locally as opposed to kind of a cloud-based API. Uh, yeah. So do you think, well, in terms of the LLM space, right? Like, do you think it's a zero-sum game? Like, in the sense, like, do you think like the company that disrupts the most will capture it all, or there's going to be, right now the space is quite disenfranchised. Most markets are going towards OpenAI, but do you think eventually it becomes a zero-sum game? Like, you look at search, right? Search is, well, in a way, you could kind of view it as a monopoly where Google owns every search query out there. Do you think LLMs are also eventually going to do it? Because Google has infinite money, infinite compute. They can give all these things for free and capture all the market share.
Um, well, what I see is that the open source models are leveling the field, such that it is becoming so that the reason why I should choose an open source model versus closed source is becoming more blurry, and it will be so what I brought earlier. So in um, tooling around it, the ecosystem, in me as a data scientist, as a developer, how comfortable I feel with something, and also which one I like the most, which one I have most experience with them, and then based on this, this is the one I will be choosing. But otherwise, I do see that I see as unlikely that, let's say, 5 years from now, uh, OpenAI will be the leading player, and with a vast distance towards like the next one. I think it will become more of a oligopoly in a sense, where there will be the large players, of course, so Amazon, Google, um, Microsoft, and other more niche players, large startups, large scale ups. but then none of them will have a majority of the market, and also the differences between these models will be much more nuanced. Because another topic that we didn't really discuss was, and it was a bit connected with the racks, is the topic of embeddings, where I think also that another area that will be more differentiation is embeddings. And with that I mean that in order to get this vector representation in our input, we need to pass it to through some model, and there are these embedding models, and at the moment is not that differentiated. So pretty much everyone takes this one from so OpenAI. Um, However, based on our task, our problem, and also how it was done, well, here will also be a zoo of possibilities, such that also I need to think not only on which LLM do I need to use my general orchestration, but also which embedding model do I use for my input. And now that we had the discussion of local models in my laptop versus cloud ones, it will also become a topic of I might have like a concert of models, meaning for very complicated tasks, I would say, hey, I take GPT-4 or whatever it is 5 years from now. It is heavy, it's expensive, but I get very precise results. But otherwise, I will be working with my smaller models that are fast, that maybe are not that precise. And if they do not know or their answer is not that good, then they will push it to this bigger model. So we'll start having like this ecosystem of likely models that are in the cloud, models that are local, maybe that are from multiple vendors. So if, for example, the Anthropic model doesn't know it, then I send it to the OpenAI model, and if not, I say, hey, I will try now also with the Llama model and so on. So it will become this orchestration of things, and that's why also this means that it will become much more of a engineering task rather than a data science activity.
Right, right. So now, if someone were to kind of get into, to getting into starting a startup centered around generative AI. I know your community heavily discusses all of those things. Uh, how do you think someone should think about it? What are the opportunities? How should you protect yourself against sort of, the large FANG players that'll, can potentially disrupt your business overnight? Like, how would you advise someone?
Yes, in the AI space, so around entrepreneurship, I would say that there is a little bit of three layers of options for entrepreneurs to build things. One is on really the lowest level of building models, building be it for embedding VLLMs, whatever it is. So here I think that it is very difficult to compete unless one is extremely well funded. So for example, Mistral, they just a few months ago they raised 100 million US dollars, and now recently the media was some reports that they're raising again 500 million. So we're talking about 600 million just in the space of 3-4 months. Not everyone can get access to this type of money. Then it's topic of tooling and so all these, let's say like LangChain, Llama Index, and similar type of tools that help you connect and glue things. Here's also quite competitive because already, for example, LangChain um, is quite established in the market, and there are other tools that are great and so on. But the community already knows it, and it becomes almost intuitive. Just as one say, "Hey, I will use scikit-learn, I will use pandas," it becomes of I need something for an LLM for an AI application. I just go and try it first with LangChain. So they become almost, in a sense, a verb or a noun for the AI field. And therefore, if I'm new and I'm starting now, almost in 2024, in this space, I really need to find um, so what type of task, with what type of problem do I want to solve with my tool in order to be able to have here an opportunity. I really think that the opportunities for anyone who wants to build with AI is more on the application space, where the reality is that AI is more than a product, is more a product enhancer, feature enhancer. And with this, I mean, um, rarely one sees just a company with a product that the only thing that it does is something connected with AI. Most of the time is, for example, let's say I have a CRM that I optimize it, I make it more efficient, faster, more precise by using some AI functionality. And this means that if I'm an entrepreneur, I should first look at so what products are available for applications in finance, healthcare, e-commerce, whatever this is. Then think about the products that are there on the market and think, hey, how can I do, for example, this AI first? I can retain the product and say, okay, Salesforce does it like this as a CRM, but Salesforce comes from another era where there was no AI. And although they have been adding AI functionality is not, let's say, AI native. So how can I like rethink this for a new generation where like the user interface will be different, how I interact with the product will be different, and try to create this product around this. And this means that as a result, the focus is more on this product, this usability, rather than the model itself. Meaning, if for example, um, so someone else, let's say Amazon or Salesforce itself, says, hey, now I will start adding this functionality because my product is already very tailored and it has much more than just the AI itself. Then it has this defensibility. It can have a chance to compete against larger players, even if the larger players later bring similar functionality.
Right. So, we've talked about mostly like American companies, American companies such as OpenAI and Google and Amazon and stuff like that. I know that you worked as a machine learning engineer at Alibaba. Uh, what do you think about China? China has been, well, at least in the mainstream, been quite soft on all of these technologies. Do you have any idea of like how do you think China is going to shape up in terms of generative AI? Do you think they're equally as competitive as the American companies?
I see that we are seeing a little bit of fragmentation of the technology and the internet space of having like islands of technology, where for political reasons, security reasons, countries are deciding, I want only to partner with the countries that I feel are similar to me. And as a result, we're seeing how um, China is becoming its own ecosystem in terms of companies, development, research, and so on. Whereas, so the US and other European countries, they are more closely aligned in what they're doing. And we haven't seen it in that, for example, so the US put some restrictions on the type of NVIDIA chips that can be shipped into China. And then what happens is that local innovation happens. And although before it was not possible to have chips with certain quality and precision, then we see reports that a local player in China has released them and seem to work very well. So what we'll be seeing is exactly that. There will be, let's say, like country L.L.M'S or country approved, where, for example, so if we are in the United States, they will say, hey, these are like the ones that you should be working with, and then if it's not in this list, then potentially you cannot use it for um, so specific industries, or you cannot use it at all. This one thing, and the other thing is also that um, the hardware will be moving into yeah, will be start fermenting. So this is like maybe like the only chance that, for example, the company has in competing with Nvidia. Meaning, if I'm, for example, based in China, then likely through the political situation, I have a chance of developing a local Nvidia player just alone because it's becoming harder and harder to get the Nvidia hardware into my country. So China has a lot of talent. They do a lot of research. And if I look, for example, into libraries that are currently appearing on GitHub, very often I find libraries from Chinese developers, and they're completely the documentation is very sparse in English. Everything is almost in Mandarin, and one can see that a lot is really happening. There's a lot of talent. So yes, it will be. I would say it will always be close or on the same level as the US, but it will be a little bit on its own world, in its own island, and maybe we that we're not there might not have access to everything that is happening there or like the models that are developing there.
Interesting to see the fragmentation of technology because generally the thing about technology was it would open borders, but I think now it's kind of going the opposite direction. Uh, China getting more isolated, and the fact that you mentioned like every country might potentially down the line have a list of LLMs that are accepted and not accepted. I think that is a pretty high possibility for sure. Because some countries may not want you to train on a certain data set and stuff like that. So, that totally makes sense. So, I guess this is the last question I have for our podcast today. But what do you think of generative AI? Do you think it's going to democratize society? Is it going to make the world more equitable, more meritocratic? How do you, you know, contemplate about the future in a post-generative AI world?
Well, on one side, I'm extremely optimistic about so the developments and all the pace of progress that we're having. But also, we should not ignore some facts that definitely this will create this will divide society into, let's say, these AI winners and AI losers. So those who are not able to adopt these AI tools, those who do not start using, let's say, ChatGPT for daily tasks, I do see that they will be left behind. There will be, of course, many professions that will either disappear or become um, financially unattractive because AI, so as GPT models, will make them so affordable. So classic example is copywriting, anything connected to, for example, logo creations and so on. So where if you think about so how much it costs to pay for a designer for a professional logo, so this is something that can cost easily so $1,000, $2,000 to have someone, and now this is pretty much free. I can go to Dali and then get a logo, get a graphic that will be a very good result, and it will cost me nothing. So we'll see a transformation of professions. We'll see a lot of people so who they will have to adapt, or basically they will not have any space in society. But also the other thing that I'm seeing is that will be accelerated. So a person will that is using AI tools definitely can become so much faster and so much more efficient. And this will translate also in demand for employees in companies, where at the moment we have many companies where there are so many employees, and then often you think, hey, what are all these people doing? And yes, we need them because some are faster, some are slower, and so on. But with all these tools, what will start happening is that we'll have these super fast, super efficient employees enabled, enhanced by AI tools, and those who are not that good, well, likely they will be let go. Companies will become smaller. We'll also see this with startups. At the moment, we think, hey, we need to raise for startups so much money because we need to hire so many people. It needs to be like 500 people and so on to be a large company. We'll move away from that. We'll start seeing startups that, let's say, have 20, 30 employees at most, but they're doing the work of a company that has 300 employees. And yes, this is great for a startup because I need less money for that. But on the other side is the question of how will happen to these other 200, 270 people who used to work or were supposed to work at that company. We need to find things to do for them. So on one side, amazing the product we're having, but also as societies, we need to think how do we bring all these people who likely will not be able to adopt these tools for a variety of reasons, which new things can we find for them to do, and what happens if in the end we cannot find employment for them? Do we need universal basic income or something like that? So very complicated thing, but in the end, I'm very optimistic that this is as a net much better for society than stopping progress.
Right. I think over the next couple decades, well, next decade, I guess, there's going to be a lot of changes in the fabric of society, and through every level, we kind of have to decide, how do we globally, well, we first as a nation and then globally as society want to progress forward, instilling all these technologies. But yep, thank you so much for coming on to the podcast, Rod, for sharing us your invaluable insights. Any other closing remarks? How can people kind of to know more about you? How can people get involved in the engineer community of yours if you just want to go through that as well?
Yes. So if anyone is interested in building AI applications and is not an expert, is for example a software developer and say, hey, I want to do AI apps, well, the best place is to go to theiengineer.co. This is the community that we're building. We're doing a lot of stuff across social media channels, for example, on LinkedIn. I'm very active on LinkedIn. People can find me there. Just Rod Rivera, or my username is RORCDE, Romeo Omega Romeo Charlie Delta Echo. And if anyone has any question, if anyone wants to reach out, then I'm always open. I always reply to all my personal messages, my direct messages. And yeah, it has been a fantastic discussion. Thank you so much for having me, Ronak.
Yep. So all the links for Rod's going to be down in the description below. So please do check it out if you're interested. And yep, thank you so much, guys.